I got here a problem. Let's understand the mechanism of this figure. Now, the diameter of rod 1 is 7 millimeters, and there is a load P that is 1,900 newtons for this boat string. Now, use the following dimensions. A equals to 105 millimeters, B equals to 205 millimeters, C equals to 180 millimeters, and for D is 95 millimeters. Now we will determine the normal stress in rod 1. Now for the solution, we will have to use TOA or tangent, which is equals to opposite over adjacent. Now tangent theta is equals to, this is theta, and the opposite side faces here, which is the length of B. And the adjacent side is this side, this portion, which is equals to C plus of D. Now we simply substitute from the given, and we have a theta that is 36.7 degrees. Now we will solve for sine theta, so simply substitute the theta and solve for its sine value. Next, we get the moment along C, which is this portion, and counterclockwise as positive. Now first, we have this force T, which acts downward, and sine is, always note that sine is the y direction of the force. Now this T will be situated here, and it will turn clockwise, which is opposite to the given moment, so it will have a negative sign. Now this sine theta has a distance of D plus of C to get to the moment at C. Now C plus D is equals to 180 plus 95 millimeters, so we have 275 millimeters. The next force is P, which acts here at the center of this mechanism. Now we will have a distance of C to get to the moment of C. Now C is equals to 180, that's why we have 180 here. And P turns counterclockwise, which follows our given direction, so that becomes positive. Now for the next is P for this sine, which has an angle of 60 degrees over here, and cosine is the x direction of the force. Now this P, imagine it will be here, and then this will turn counterclockwise to get to C, so that is why it is positive. Now cosine of the angle 60 degrees times of 180, which is still the given value of C, which is 180 millimeters as the distance. So cosine the angle of times the distance. Now we also consider the P force along sine, which is the y direction. Now we will have to consider the angle sine 60 and the distance, which is the A, to get to the moment of C. Now that is 105 millimeters. So we need to solve for T, which is the tension force that acts here. Now let's break this down. Let's first write negative T sine theta times its distance, which is 275. Next is the plus P, which is given in our problem as 1,900 newtons times its distance of 180 plus P P cosine of 60 degrees times 180. So that is plus P equals to 1900 newtons cosine of 60 degrees times 180. Next is the sine, which is the y direction of the force P. So plus 1900 newtons sine 60, and its distance is 105 millimeters, which is the variable at A, and that is equals to 0, the moment C. Now upon solving, we first get 1900 times 180, which is equals to 342,000, this one, and then this answer we plus it by 1900 newtons cosine of 60, and then make another parenthesis for this distance 180, and that equals to 513,000. We now have 513,000 for this 2, and we add this one. So add again of 1900 newtons sine of 60 times 105 millimeters, which is the distance at A, and we obtain this value. Let's first write this one here, 685,772.0681 equals 0. Now this one we have solved already. Let's cancel out the things that we have solved. So we are left with negative t sine of theta times 275. Excuse me for my writing. And this one will be our new equation. Now we transpose this one to the other side, which will make it negative. And then we will incorporate the negative t sine of theta 275 still on this side, on the left hand side, and then sine theta is equals to 0.597665 times of 275. So we get this coefficient for t, which is 164.357875 negative of t equals, still bring this down, negative 685,772.06. Next is we will solve for t. Now negative of 685,772.06 is divided by negative of 164.35785, and that equals to P as 4172.432 newtons. This one. And then to solve for the normal stress in rod 1, we will get the symbol sigma 1, and this is tension over the area of a circle, which is pi 4 d squared, equals to, just substitute the values that we have solved earlier, and we have the d as given in the problem, 7 millimeters squared, equals to 108.4184 megapascals.